like this: a1x plus b1y plus c1 equal to 0, and a2x plus b2y plus c2 is equal to 0. Or you can represent the equation like that: is equal to c1 is equal to c2. Now this pair of linear equation can be represented in matrix form like that: a1 b1 a2 b2 multiplied with x y is equal to c1 c2. That means in the form of ax is equal to b, where a equal to the 2 cross 2 matrix a1 b1 a2 b2, x equal to the column matrix x comma y, and b equal to the column matrix c1 and c2. Now we know that from class 10 that this type of equation possesses a unique solution or no solution according to the condition a1 by a2 not equal to b1 by b2. Means if a1 by a2 is not equal to b1 by b2, then the set of these two equation possesses a unique solution. That means a1 b2 minus b1 a2 is not equal to 0. This term is called a determinant of order 2. So actually what is the determinant? So determinant is nothing but a mapping from a set of matrix to a number. The number may be a real number or a complex number. Means okay, let us define a mapping. Let M is a set of all square matrix, and suppose K is a set of all number. If we define a mapping F such that M to K by f of A is equal to K, for A belongs to M and K belongs to K. So this is called, then f of A is called determinant of the matrix A. So determinant of the matrix is nothing but a value which assigns to a fixed matrix. Okay, now we'll discuss a different type of matrix and how we can expand it. Okay, so look, I told you that the determinant must be of a square determinant. Means the order of the determinant may be 1 by 1, 2 by 2 or 3 by 3. So we will discuss how to expand a determinant. Okay, so starting with a determinant with order 1 cross 1. So let us consider a matrix of order 1 cross 1, suppose 2. So obviously this is a matrix of order 1 by 1, 1 cross 1. Now determinant of A is denoted by either det A or by this symbol, and determinant of A will be determinant of 2, and that is equal to 2. So for a determinant of order 1, the determinant value of the determinant is equal to that number. Now if I consider a determinant of order 2 cross 2, means suppose A equal to suppose A1 1, A1 2, A2 1, A2 2. So this is a matrix of order 2 cross 2. Now determinant of A is equal to det of A11, A12, A21, A22. Now it has a procedure how to expand this one. Now look, first we have to multiply these two numbers diagonally, means A11 into A22, and then put a negative sign, and then multiply these two elements, means A21 with A12. So A12 into A21. So this is the procedure how to expand a 2 cross 2 determinant of, or a determinant of order 2. Okay, I am giving an example. Suppose if I choose a determinant like that. Suppose let delta is a determinant which is equal to suppose x plus 1, x minus 1 and x. Now we have to expand this determinant. So I told you the rules. Here we have to multiply this element with this element. So x is A11 multiplied with A22, means this element. Put a negative sign here, and then A12 means x plus 1 into this element x minus 1. Now calculate this one. So x into x is equal to x square, and this one is x plus 1 into x minus 1, and that is equal to x square minus 1. Now remove the bracket. So x square minus x square plus 1, that is equal to 1. So this is the procedure how we can expand a determinant of order 2 cross 2. Now we'll choose a determinant of order 3 and see how we can expand a determinant of order 3. Okay, so let us choose a determinant. Let delta equal to determinant of A11, A12, A13, A21, A22, A23, A31, A33, A32, A33. Now look, we know the arrangement along horizontal arrangement is called a row, and the vertical arrangement is called a column. So this is the first row, this is the second row, and this is the third row. Now we can expand a determinant with respect to along any row or any column. We can expand the determinant along this R1, means row number 1, or we can expand the determinant along second row or third row, and similarly for the columns. So I am expanding the determinant along with the first row. Okay, so the determinant will be, look, A11 into, okay, so when we taking this element, so the entry corresponding to this row and this column cover this one and this one. So we have this portion, so write this one A22, A23, A32 and A33. Then put, okay, then plus minus 1 whole to the power 1 plus 2, means 1 plus 2, A12 determinant of, okay, now cover the element corresponding to the first row and second column, means cover this element, this row, this column and this row. So we have A21, A23, A31 and A33. Similarly, when we choose this element, means the last one, so we have minus 1 whole to the power 1 plus 3 into A13 determinant of, now if you cover this column and this row, so we have A21, A22, A31 and A32. Now we can see that this is a determinant of order 2, this is the determinant of order 2, and this is also a determinant of order 2, and we know how to expand a determinant of order 2. Just we have to first multiply these two elements minus we have to multiply these two elements. This is the procedure to expand a determinant of order 3. I am giving an example. It will, okay, so let us choose a example. Suppose let delta equal to determinant of 1, 2, 4, minus 1, 3, 0, 4, 1, 0, and we'll expand this determinant along the first row. So look, always remember this chart. First element will be plus, minus, plus, minus, plus, minus, plus, minus, plus. So if we choose the if we expand the determinant along the first row, so we'll take plus for the first term, minus for the second term, and again plus for the third term. So we first expand this determinant along the first row. So first element is plus 1, determinant of, now cover this row and this column. So we have this block open, so it is 3, 0, 1, 0, and next sign is negative, so minus 2, determinant of, now cover this column and this row. So we have minus 1, 0, 4, 0, and next sign is positive, plus 4 into, now if I cover this row, this column and this row, so we have minus 1, 3, 4 and 1. Now this is a 2 cross 2 determinant, we can easily expand it. So 1 into 3 into 0 is equal to 0, minus 1 into 0 is equal to 0, minus 2 into minus 1 into 0 is equal to 0, minus 4 into 0 is equal to 0, plus 4 into minus 1 into 1 is equal to minus 1, and minus 3 into 4 equal to 12. Now, so 1 into 0 minus 2 into 0 plus 4 into minus 13. So this is 0, minus 0 and minus 13 4s are 52, and that is the answer equal to minus 52. So this is the way to expand a determinant of order 3 cross 3. If we expand the determinant along a first row, now instead of first row we can choose any other row or column, the result will be same. I am showing you. If I expand the same determinant with respect to suppose this column, okay, then what happened? Okay, so first is 2 and the sign will be negative, so minus 2 determinant of column and this row, so we have minus 1, 0, 4, 0. Next sign is positive, so plus 3 determinant of, now cover this row and this column, so we have 1, 4, 4, 0, and next sign is minus, so minus 1 determinant of, now cover this column and this row, so we have 1, 4, minus 1 0. Now expand it. Minus 2 into, multiply these two numbers, so minus 1 into 0 is equal to 0, minus 4 into 0 is equal to 0, plus 3 into 1 into 0 equal to 0, and minus 4 into 4 equal to 16, minus 1 into 0 equal to 0, and minus 4 into minus 1 is equal to minus 4, and minus minus, that will be plus. So that is minus 2 into 0 plus minus 3 into 16 minus 4. So that is equal to minus 0, and 16 3 is 48 minus 4, and that is equal to minus 52. So the result is same. Whatever we are choosing the which row or which column, the result will be always same. Okay, so this is the procedure how to expand a determinant of order 2 by 2, or means order 2 and of order 3. Okay, now we'll solve some examples problem. Okay, so let us solve some problem. Let's start exercise number 4.1. Exercise number 4.1. Now the first question is evaluate the determinant in exercise 1 to 2. Okay, so first question is determinant 2 4 minus 5 minus 1. So this is a determinant of order 2, and we know how to expand this one. So we have to first multiply this two corner element minus this two element. So this is equal to 2 into minus 1. First multiply these two element minus multiply these two elements. So 4 into minus 5. So that is equal to 2 into minus 1 means minus 2, and 4 into 5 means minus minus plus, 4 5s are 20. So 20 minus 2 is equal to 18. So 18 is the answer. Okay, now question number, suppose 2 1. Question number 2, support 1. We have to determine the value of the determinant cos theta minus sin theta cos theta. So the rules is same. We have to multiply this two corner element minus these two element. Okay, so let's do it. So cos theta into cos theta, so cos theta into cos theta, this two element, minus multiply this two element means minus sin theta into sin theta. So that is cos multiplied cos means cos square theta, and minus minus plus, sin theta into sin theta is equal to sin square theta. And we know that that sin square theta plus cos square theta, the value is equal to 1. That means the value of the determinant is equal to 1. Okay, okay, so let's solve the next one. Suppose I am solving question number 4. There is a determinant of there is a matrix A is equal to 1 0 1 1 0 1 0 1 2 0 1 2 0 0 4 0 0 4. We have to find we have to show that 3 of mod A we have to show that 3 determinant of A, determinant of 3A is equal to 27 into determinant of A. We have to prove this one. So A is given, so find determinant of A. So determinant of A will be 1 0 1 0 1 2 0 0 4. Now if we expand the determinant with respect to the first column, because it contains maximum number of 0, so expanding the determinant along the first column, we have 1 into determinant of 1 2 0 4, and remaining 2 determinant will be 0 into something, and we know that 0 into something, that is equal to 0. Okay, so if I multiply this one, so 1 into 1 4 is 4, so that is equal to 4. So value of the determinant is equal to 4. Now we will calculate the value of the 3A, value of 3A. Okay, so I am solving it here. So if A equal to this matrix, so what will be the value of 3A? 3A will be, we know from the matrix that if you multiply a matrix by adding a scalar quantity, so we have to multiply each element of the matrix with the scalar quantity. So here we have to multiply each of the element with 3. So 1 into 3 will be 3, 0 into 3 will be 0, 1 into 3 will be 3, 0, 1 into 3 is equal to 3, 2 into 3 is equal to 6, 0, 0 and 3 4s are 12. So this is the value of 3A. Now if I expand the determinant with respect to along the first column, so we have determinant of 3A is equal to 3 into 3 6 0 12, and remaining 2 will be 0 because both are 0. So that is equal to 3 into 3 12s are 3 into 12 minus 0 into 6. So that is 3 into 12. Now that this can be written in the form 3 into 3 into 3 into 4. 4 3s are 12. So that is equal to 27 into 4. And value of determinant of A is equal to 4. So that is, we can write determinant of 3A is equal to 27 into 4. 4 means determinant of A, means determinant of 3A is equal to 27 into determinant of A, and hence proved. Okay, now I'll solve one problem. Suppose question number 5.1. Question number 5.1. So question is determinant of 3 minus 1 minus 2 0 0 minus 1 and 3 minus 5 0. We have to calculate the value of this determinant. Now look, if you look, this row means row number 2, it contains maximum number of 0. So if we expand the determinant along the row 2, it will be easy, but you can choose any row or any column, as we know that. So we are choosing this row to determine the. Okay, so now look, we know the rules, that is plus minus plus, minus plus minus, plus minus plus. So if we expand the determinant along the second row, so the sign will be consecutively minus, plus and minus. So for the first it will be 0. For the second it will be also 0, and for the third one, from the rules, it will be minus and -1 into, now omit this row and this column. So we have 4 element here, 3 -1, 3 and -5. So that is minus minus a +1 into 3 5s are -15, and this is a +3. So that is -15 plus 3 is equal to -12. So -12 is the answer. Okay, you can choose another problem. Suppose question number, suppose 3. I am doing the third question. Question number 3. So question number 3 is 1 0 1 2 0 1 2 -1 0 3 and -2 3 0. Okay, so expand the determinant. So if we expand the determinant along the first row, so it will be 0 into something, so that is 0. Next sign is -1, and this one. So delete this column and this row. So we have 4 element, -1, 3, -2 and 0, and then 2 into -1, 0, -2 and 3. Now expand it. So -1 into 0 equal to 0, -2 6, plus 2 into -3 into 1 equal to -3, and it is a 0. So that is -6, and this is -3 to the 6. So -6 is equal to -12. Okay. Okay, so this is question number 5. Now I am doing question number suppose 7, any one of them. Question number 7 is we have to find the value of x if suppose I am choosing question number 1. If the determinant 2 4 5 1 2 4 5 1 is equal to 2x 4 6x 6 and x. Okay, so on the left hand side we have a determinant of order 2, and on the right hand side also we have a determinant of order 2. So first expand the 2 determinant. So if I expand the determinant of the left hand side, so it will be 2 into 1, that is 2, minus 5 into 4, that is equal to 20, is equal to, now expand the determinant on the right hand side. So 2x into x, that is equal to 2x square, minus 4 into 6, that is equal to 24. Now this is obviously linear equation in quadratic equation in one variable, and we know how to solve this type of equation. So solve it. So that is 2x square minus 24 is equal to minus 18. That is equal to 2x square is equal to minus 18 plus 24. That is equal to 2x square is equal to, so it is that is equal to 6, or x square is equal to 6 upon 2, that is x square is equal to 3. Now we know that if x square equal to 3, then value of x equal to plus minus root over of 3. So value of x is either plus 3 root over of 3 or minus root over of 3. Okay. Now you can see the next question, question number 2 is of the same type. Okay, I'm doing the last one, means question number 8 of this exercise. Question number 8 is, we have to find the value of x if x to 18x is equal to 6 to 18 and 6. Okay, now expand the determinant. So on the left hand side, multiply these two elements. So x into x is equal to x square, and 18 into 2 is equal to minus 36. That is equal to 6 6 are 36 minus 18 2 is 36 again. So the expression on the right hand side is equal to 0. So x square minus 36 is equal to 0. That means x square is equal to 36, means x is equal to plus minus root over of 36. That means x equal to plus minus 6. So value of the x equal to plus minus 6. That is your option B. Okay, so, and that was the last question of the exercise 4.1. Okay, so I think you know understand how we have to expand a determinant of order 2 cross 2 or a determinant of order 3. Okay, now we'll learn some properties of determinant. Now we'll learn some property of the determinant. Okay, so the first properties means the value of the determinant remain unchanged if we change row and columns. Means suppose there is a determinant delta like A, B, C, B, C, D, E, F, G. Suppose this is a determinant. So this is the first row, this is the second row, and this is the third row. Similarly, this is the first column, this is the second column, and this is the third column. Now value of the determinant does not change if we change the row and column. Means if I write the first row as a column A, B, C, and the second row as a second column B, C, D, and the third row as a third column E, F, G. So value of the determinant does not change. So delta will be equal to delta 1. Means if we change the row and column of a determinant, so value of the determinant does not change. I am giving an example. Suppose let us choose a determinant. Suppose 2 minus 3 5 6 0 4 1 5 minus 7. Okay, so this is a determinant of order 3. Now expand the determinant. Suppose I am expanding the determinant along the first row. So it will be 2 into 7 into 0 is equal to 0 into minus 7 minus 4 into 5. Second sign is minus, so minus 3 into, now cover this column and this row. So we have 4 elements, 6, 4, 1 and 7. So 7 into 6 is equal to 42 minus 4 into 1 is equal to 4, and then plus 5 into 5 is 30 and 1 0 is 0. Okay, now so it is 2 into 0 minus 20 minus, sorry, it is minus 3. So minus minus plus 3 into 42 minus 4, that is equal to 46, plus 5 into 30, and that is minus 40, and this is equal to minus 3 6 are 18, 12 and 13, and plus 5 3 is 150. So that is equal to 8 7 1 minus plus 150, and that is equal to minus 28. Okay, that is equal to minus 8. Now if we take another determinant, suppose delta 1, by changing the row and column, means 2 6 1, means we are writing the first column as the first row of the another determinant, and minus 3 0 5 and 5 4 7. Okay, and if we expand the determinant again, so we have suppose I am expanding the determinant along the first row, so it will be 2 into 7 into 0 is equal to 0, and 5 into 4 equal to minus 20, plus, sorry, next sign is minus 6 into, so 3 into minus 7 is equal to minus 21, minus 5 5 is 25, plus 1 into 3 4 is minus 12 minus 0. So that is equal to 2 into minus 20 minus 6 into minus 46, and that is minus 12. So that is 4 minus 40 plus, excuse me 1 second, I'm expanding the determinant along the second row. It contains a 0, so it will be easy. So the rules is plus minus plus minus plus minus plus minus plus. Okay, so minus of minus 3, determinant of 6 1 4 7 and 0, minus 5 of 2 6 5 4, that is equal to 3 into 6 7 is 42 minus 4, and minus 5 into 2 4 is 8 and 30, that is 3 into 38 minus 5 into minus 22, so that is equal to plus. So it is plus excuse me, I think I am doing some mistake. 2 6 1 2 6 1 2 6 1 3 0 5. Oh, I'm sorry, this is minus 7. This is minus 7. So excuse me, this is minus 7, so it will be 2 into 0 minus 20 minus 6 into 21 minus 25 plus 1 into minus 12 minus 0, that is minus 40, and 4 6 24, and this is minus 12, so that is minus 52 plus 24, that is equal to minus 28. Okay, So you can see that the result means the value of the determinant does not change if you write the row into column. Means if we interchange the row and column, then the value of the determinant does not change. So this is the property number 1. Now property number 2 is if any two row or any column are interchanged, then the sign of the determinants changes. Means if we change any two row or any two column, then the value of the determinant change the sign. Okay, so for example, let delta equal to suppose 2 minus 3 5 6 0 4 1 5 minus 7. Okay, so we are taking the previous example and the value of the determinant is minus 28. Okay, now if I change any two row or any two column, so the value of the determinant does not change. Means if I interchange between these two row, then delta 1 is equal to 2 minus 3 5, okay, 1 5 minus 7 6 0 4. We are interchanging the row 2 and row 3, and we'll calculate the value of the determinant and see what's coming. So 2 determinant of 5 minus 7 0 4 plus 3 determinant of 1 minus 7 6 4 plus 5 determinant of 1 5 6 0. So that is equal to 2 into 4 5s are 20 minus 0 plus 3 into 1 4s are 4 plus 4 7s are 42 plus 5 into 0 minus 30, that is equal to 40 plus 3 into it is 46 plus minus 5 into minus 30 means 150. So that is equal to 40 plus 3 6 are 18, 1 carry 3 4s are 12, 13 minus 150, and that is equal to 178 minus 150, and that is equal to 28. 20, only 20 means plus 28. So value of the original determinant is equal to minus 28, and when we interchange any two row or column, then its value becomes positive. Means value of the determinants, its sign changes when we interchange any two row or any two column. Okay, now property number 3 is if any two row or any two column of a determinant are identical, then the value of the determinant is equal to 0. What do you mean by identical? Identical means if any two row or any two column of a determinant are same, if the corresponding entries are same, then the value of the determinant is 0. I am giving example. Suppose suppose let us choose a determinant delta is equal to suppose 1 2 3 2 3 5 1 2 3. Now you can see that the row number 1 is identical with row number 3, means first row is identical with the third row. So if I expand the determinant, the value will be 0. See, if I expand this determinant like that, 1 into determinant of 3 5 2 3 minus 2 determinant of 2 5 1 3 plus 3 determinant of 2, 3, 1, 2. That is 3 3 is 9 minus 10. 1 into minus 2 into 2 3 is 6 minus 5 plus 3 into 2 2 is 4 minus 3. That is equal to 1 minus 2 into 1 is 2, and this is plus 3. 2 3 is 2 into 1 2, and this is 3. 1 into 2 5 2 3, 2 into 2 5 1 3, 3 into 2 3 1 2. So 1 into 9 minus 10, 2 into 6 minus 5, 3 into 4 minus 3. That is equal to 1 into, this is 1 into minus 1, this is minus 2 plus, so that is minus 3 plus 3, and that is equal to 0. That means any two row or any two column of a determinant are identical, then the value of the determinant is equal to 0. Now property number 4 is suppose there is a determinant like this. Suppose A11, A12, A13, A21, A22, A23, A31, A32, A33. Now if I multiply any row or column with a fixed number and add the result with corresponding element of that row or column, then the value of the determinant is do not change. Means suppose we are multiplying suppose third row with a scalar quantity and then add with the first row, then the value of the determinant does not change. Means A11 plus k into A31, A12 plus k into A32, A13 plus k into A33, and remainings are same: A22, A23, A31, A32, A33. The value of the determinant does not change. I am giving an example. Suppose let us choose a determinant delta which is equal to, suppose a plus lambda into c plus b, sorry, 1 second, a suppose this is a determinant. Okay, now if I take another determinant such that the first element is a plus lambda, a plus suppose k into g, h g, h plus k into f, b f, and g plus k into c, f and c. Okay, so value of this determinant and value of this determinant will be same. See how this determinant can be written in the form, that is a h g h b f g f c plus kg kf kc h b f g f c. That is equal to a h g h b f g f c plus If I take K common, so it will be G F C H B F G F C. Now for the second determinant, the first column and the third column are identical. So we know that if any determinant, if any two row or column are identical, then value of the determinant is equal to 0. So value of this determinant is equal to value of this determinant. Okay. Okay. Now okay, now we'll solve some problem from your book. Okay, so let's start exercise number 4.2. Okay, so start exercise number 4.2. Exercise number 4.2. So you have to using the property of the determinant without expanding exercise 1 to 7, prove that. So the first question is the determinant of x a x plus a, y b y plus b, z c z plus c is equal to 0. Now this determinant can be written as the sum of two determinant with the entries x a and the first element x, y b and the first element y, z c and the first element z, plus x a and the second element a, y b and the second element b, z c and the second element c. That is equal to. Now look at the determinant. The first column and the third column are identical, and we know that if any two row or any two column of a determinant are identical, then value of the determinant is 0. Similarly, for this determinant, the second column and the third column is identical. That means this determinant is also 0. So 0 plus 0 is equal to 0. So value of this determinant is equal to 0. Okay, so I'm doing another questions. That will be our last question today's. Okay, so without expanding, we have to prove that. I'm doing question number 4. Without expanding, we have to prove that determinant of 1 BC and a into b plus c, 1 ca b into c plus a, 1 ab and c into a plus b is equal to 0. We have to prove that this determinant is equal to 0. So we are starting with let delta equal to this. Okay, that means delta equal to 1 BC and it is AB plus AC. If I remove the bracket, then it will be AB plus AC. Second row will be 1 CA and BC plus AB, and third row will be 1 AB and it will be AC plus BC. That is equal to, now if I do a operation here, that is C3 dot is equal to C3 plus C2, then see what happened. First column is unchanged 1 1 1, second column is unchanged BC CA AB, and third column is just add these two element, means AB plus BC plus CA, and here also AB plus BC plus CA, and third is AB plus BC plus CA. Now AB plus BC plus CA is a common element of the third column, so we can take that element common. So if we take AB plus BC plus AC, if we take common, So it will be 1 BC 1, 1 CA 1, 1 AB 1. So that is equal to AB plus BC plus CA into 0. Why 0? Because look at the determinant, the first column and the third column are identical, so value of the determinant is 0. So AB plus BC plus CA multiplied with 0, and we know that anything multiplied with 0 is 0, so that means value of the determinant is 0. Without expanding we can prove that. Okay, so next we will solve the remaining problem of the exercise 4.2. You can also try to solve this at your home. Okay, thank you.